Hi students, now we will solve a numerical problem in Doppler effect. The first problem. A listener is at rest and a police siren is moving away from the listener at 60 meters per second. What frequency does the listener hear given that the velocity of sound in air is 340 meters per second and the frequency of the siren is 500 Hz. So first, whenever you read any numerical problem, understand. You read till you understand and then write the given information correctly. So the actual frequency of the siren is F. So F is equal to 500 Hz is given. Then a listener is at rest is given. So the velocity of the listener, which is also equal to velocity of the observer. So this is equal to 0. Now the police siren is the source which is moving at 60 meters per second. So this is moving away is given. Okay, away from the listener at 60, moving away. Anyhow, the value alone I will write. So velocity of the source is equal to, here minus 60 we can write. If you want, I will write minus 60 first itself. So minus 50 because it is receding. Okay, it is receding away from the stationary source. Okay, what frequency does the listener? If the velocity of the sound in air. So the velocity of the sound in air is 340 meters per second. Then what else is given? That's all I think. So what we have to find is the apparent frequency F dash in this case. If they have not mentioned about the medium means it can also be taken as what is 0. Okay. Now the general expression. What is the general expression? So let us start with the general expression irrespective of the cases. Okay. The general expression is apparent frequency F dash is equal to actual frequency F into V plus V medium minus V listener or observer divided by V plus V medium minus V source. So here M medium Vm is equal to 0 and observer also is at rest. So F dash is now equal to F into. So these two get cancelled. This is V divided by V minus of Vs. When the source is receding, its value has to be taken as what? Minus 60. So minus of minus 60. So I am going to substitute this is equal to F. F is how much? 500. So 500 into the velocity of sound has to be taken as 340. So this is 340 divided by V minus Vs. So 340 minus, here minus of minus is it not? So minus of minus 60. So this is equal to 500 into 340 divided by 340 plus 340 plus 60. So this is 400. Therefore, the apparent frequency F dash is equal to 500 by 400 into 340. So these two get cancelled. So this is 5 by 4 into 340. So 340. So this can be cancelled. 8 fours are 32. 8 fours are 32 and remaining 20. So 5 fours are 20. So 5 into 85. So this is equal to 5 into 85. So this is 80. This can be written as what? 80 plus 5. So that this is 400 plus 25. So that this is 425. You can also use calculator. Understand, it is the shortest method which I am suggesting you. Okay. Therefore, the apparent frequency F dash is found to be 425 Hertz. So that has to be found here. The actual frequency is 500 and the apparent frequency is 425 because the source is going away from the stationary observer. It is receding. So we have clearly understood one of the special cases in the Doppler effect. This is the easiest possible problem in Doppler effect. Always when you learn any concept, go from easy to the tougher one. Okay, from known to unknown. Okay, I hope you must have understood this well. Fine.